Okay, in the last video, it was getting a little long. We were talking about adding vectors, and we're going to add in right now subtracting vectors. And when I think of it, when I think of a minus b, I think of it adding a and negative b. Now, negative b is the same as b. It's just pointing in the opposite direction. So in a scale model, just draw it flipped around going the other way. For components, you can just switch the signs of both components. So b actually become negative b and so on. So we're going to do this example and try to get the try to find what a minus b is going to be. Okay, so my first thing I'm going to do is draw a scale model of it. So I'm going to use a scale of 1 centimeter, 10 units, and I'm going to draw that down here. So I'm going to put the origin right here. So I'm going to draw that. And I'm going to watch me setting it up. Okay, so now I've drawn in A and B. But I don't want to do A plus B. I want to do A minus B. So I don't really need B here. I need negative B. So what I set up above was it just has to point back in the opposite direction. So I'm going to draw negative B pointing back the other way. That is going to look like this. And there is negative b back in the opposite direction. So now I have a and I have negative b, but unfortunately they're tail to tail. I have to make them tip to tail. So I'm going to move negative b over to the end of A. So I would take my protractor over here, put it here, and mark off my degrees, and then I'm going to measure out along that I. Again, you don't need to watch me do it, but I'm going to do it on you. So there is negative b. Now to find the result of that, I'm just going to draw it in the origin, the last thing I drew. So now I need to find the length. So a minus b has a length of basically the length from about 3 to about 5, so 2. So that's 20. And an angle looks to me like that. Okay, so 75 degrees here. One way of stating that is 75 degrees above negative x. This is the dotted line enters the negative x-axis. I just want to 75 degrees above that. Now, I should get the same value if I use the component method. So for the components, I'm going to redraw A and B. I have A going over this way at 40. So AX is going to be 40. AY at 0. B goes down this way. So BX is here. The angle is 20 degrees. B is 51. So BX, I'm going to use the cosine because it's the adjacent side. So it's 50 cosine 20. That gives me a value of 47. And then BY is going to be 50 sine 20. And that's going to give me a value of negative 17.1. But I'm not trying to find A plus B, I'm trying to find A minus B. So A minus B, the component of that in the x direction is going to be the A 40 plus minus B. So minus B actually is minus 47. So that's going to tell me the x component of this is going to be minus 7. And A minus B's y component going to be AY, which is 0, plus DY was negative 17.1, so it's going to be positive 17.1 for negative D. And that's going to give me a value of 17.1. Now I just need to draw it. The x component is negative 7, so 7 negative x direction, 17.1 in the y direction, and there is my resultant of A minus B and my angle. So A minus B squared is going to equal 17.1 squared plus 7 squared. And that's going to give me A minus B as a magnitude of 18.5. And then if I find that angle, tangent theta is equal to the opposite, which is 17.1, will be adjacent, which is 7. And if I put that in my calculator, I end up with an angle of 68 degrees. So, you now should know how to add vectors and how to subtract vectors using both scale models and